Assalamualaikum, my big to doctor and all. So for today, our group will be presenting on application of green chemistry in chemistry/chemical engineering. We are from group 3 and these are the fellow group members. I am Siti Aisyah binti Abdul Malik, leader of the group, and my teammates are Ali Chabli, Adriana Hajar, Nur Aisha, Nurul Sharafana, and Nick Nur Nasuha. So let's start with the introduction of green chemistry. Green chemistry can be defined as a science-based philosophy that aims to create chemicals, products, and processes that are safer and more environmental friendly. It applies to a product's entire life cycle from conception to disposal. By producing safer chemicals, green chemistry can prevent pollution as its source. At last, the use of toxic chemicals less frequently or never at all to protect the environment, consumers, and workers can increase the use of renewable materials while reducing the use of energy and materials.
Now, let's start with our first application, chemical engineering in green chemistry in Malaysia, which is Green Hydrogen Project. As we all know, Malaysia's oil and gas reserve have proven resilient in recent months despite increased concerns about energy security because of recent invasion of Ukraine. However, in the coming decades, the country must stop using fossil fuels and prepare for a low-carbon future. This is because fossil fuel is a non-renewable feedstock and it will be gone in the future. So what Malaysia did was, Sarawak in particular is attempting to attract companies eager to embark on large-scale hydrogen projects thanks to its significant hydropower and natural gas supplies. Sarawak launched Southeast Asia's first hydrogen power buses in Kuching in 2019 as part of a proof-of-concept project that also featured a small hydrogen generating plant. Since then, the state hydrogen emissions have quickly grown. The Sarawak H2Biscus Green Hydrogen project, the largest proposal to date, will be developed by South Korea companies Samsung Engineering, Lloyd Chemical, and POSCO, as well as SEDC Energy, a wholly owned subsidiary of Sarawak Economic Development Corp. Next, the project, which is scheduled to open in January 2022, will convert hydropower into green hydrogen and methanol and natural gas into blue hydrogen, as well as convert hydrogen to electricity. In April this year, state-owned Petroleum Sarawak Petros launched its first multi-fuel station in Darul Hana, which is able to cater to vehicles powered by either conventional fossil fuels, electricity, or hydrogen.
Hello, Doctor. This is Ali Shibli. My part is to explain more about what green hydrogen is. So, green hydrogen, or GH2, is hydrogen produced using low-carbon power sources or renewable energy. Green hydrogen can be blended into exciting natural gas pipelines and also used to produce green ammonia. It's suggested by hydrogen industry bodies that green ammonia will be cost competitive with ammonia produced conventionally, grey ammonia, by 2030. The cost of hydrogen production could fall from $6,000 per kilograms in 2015 to around $2,000 per kilogram by 2025. Less than 0.1% of all hydrogen produced is green hydrogen, which is produced through electrolysis of water. It might be used to decarbonize industries that are difficult to electrify, such as steel and cement. Green hydrogen has much lower carbon emissions than grey hydrogen made by steam reforming natural gas. So this is the green hydrogen definition, and I actually related a principle in the fifth slide, the second one, designing less hazardous. My friend actually talked about this in her voice recorder. Yeah, so this is my research and my work, Doctor. Thank you.
So what is actually relation between green hydrogen project with principle of green chemistry? Here we have two relations. The first one is use of renewable feedstock. Green hydrogen is produced using exclusively renewable energy sources such as hydro, solar, and wind rather than other equivalent chemicals originating from petrochemical sources. Next, the second one is designing less hazardous chemical synthesis. It is one of the most important principles in green chemistry. Less hazardous chemical synthesis means designing synthesis to use engineered substances with little or no toxicity at all to either humans or the environment.
Our second application is recycling plastics. Tanam Industri Sdn Berhad is a well-known company that are experienced in supplying recycled waste and then manage them properly. So this is a family-run company that has operated since 1999 with the tagline of "For a more livable environment." This company collects electronic waste such as old handphones and then plastics, paper, and metal scraps to form new products that beneficial to people. But in this application, we are going to focus only on recycling plastics. Plastics are made of petrochemical, which is the combination of petroleum and other chemical products such as ethane, propane, butane, and other hydrocarbons that are recovered from crude oils and natural gas liquids. So, why do we need to recycle plastics? It is because if we want to make more plastics, more petrochemical products are needed. And to prevent depletion of petrochemical stocks, we should recycle the plastics instead to form new products. So recycling plastics process starts with classification plastics according to their density because different type of plastics has different types and size and also its density. Then the plastic is broken down into small parts or flakes and then they are going to be heated into high temperatures so that it can be molded, pelletized and packaged in quantities needed to form the desired products.
Next, Tanam Industry produces petrochemical products such as plastic. Their plastic was made from plastic recycling, where they reprocess plastic waste to new plastic products, in which they applied the green chemistry principle number 1, which is waste prevention. The process of waste prevention involves collection, sorting, shredding, washing, extrusion, and creating new plastic products such as PVC and HDPE plastic. In the plastic extrusion, there is a polymerization process and it uses the principles of green chemistry such as catalysis and design for energy efficiency. For example, in producing HDPE plastic products, it is produced by the additional polymerization of ethylene. The properties of polyethylene depend on the manner in which ethylene is polymerized. When catalyzed by organometallic compounds at moderate pressure, the product is high-density polyethylene (HDPE). So, HDPE plastic has been used by the Tanam industry to produce construction pipes. Manufacturing recycled plastic only uses 30% of energy required for making original plastic from fuse.
So the next is palm oil detergent. Palm oil as a primary ingredient in detergent. The palm oil comes from a palm fruit and after that one kernel per fruit. So we process it under a chemical process until it using a short chain fats. And it is usable after processing into fat-based derivative. The product of palm oil production mostly used in non-food applications such as surfactant and soup production. Basically, chemical engineers are equipped to design and operate industrial plants and equipment to convert raw materials into finished products. Their specialty on one specialty, such as soap and detergent, are on a diverse range of products. Malaysian Palm Oil Board (MPOB) encourage entrepreneurs to use palm oil in soap formulation. The current consumer demand can be seen under the use of palm-based soaps as the key ingredient of natural origin, safe and environmentally friendly. Manufacturing of detergent from distilled fatty acids of palm kernel oil and palm oil is a well-established technology in Malaysia. The production of detergent from palm kernel oil is by direct saponification of fats and oils and is evaluated for water hardness, pH value, viscosity, and foamability of liquid detergent. The palm oil and palm kernel oil as raw material have important fatty acids involved in detergent making, which are C16, C18, C12, and the C14, which contribute to the detergency properties such as fatty acid and fatty alcohol. So you can see the process of making detergent. Benefits of palm oil detergent. Firstly, it is environmentally friendly because it using natural ingredients. Secondly, it is safe to human and environment because it using less hazardous chemicals in the process of making detergent. Lastly, it is easily biodegradable because it is using natural ingredients and less hazardous chemicals in the process of making the detergent, and it's safe to the environment. So that's all from me.
Assalamualaikum, Aisha Malik speaking. So now I'll be explaining the principle of green chemistry that are related to the example of application in chemical engineering. First, less hazardous chemical synthesis. As we know, this means generating substances that possesses little or no toxicity to human health and the environment. As for this example, the use of palm oil as the raw material from ester then to sulfonated metal ester causes it to become softer, which is safe for human skin daily use. Second, use of renewable feedstock. As we know, raw materials should be renewable and economically practical. We are widely aware that our country's palm kernel oil and palm oil is a well-established technology. So as for this, the detergent industry has been investing in optimizing palm kernel oil as a bio-based raw material and is committed to sustainable sourcing. Lastly, the principle of green chemistry that is applicable is to reduce derivative. This can be defined as unnecessary derivatization should be avoided whenever possible. Back to the example, palm kernel oil derivatives are used as surfactants in detergent to ensure an adequate cleaning functionality as they attack and remove dirt. That's all from me. Thank you. As a conclusion, all over the world, governments and industry are working with green chemists to transform the economy into sustainable enterprise. And who knows, green chemistry may be the next social movement that will set aside all the world's differences and allow the creation of an environmentally commendable civilization. Elon Musk once said, "We have no desire to do the best green chemistry. We will do the best chemistry and it will happen to be green." That's all from us. Thank you so much.